Hello everyone. In this video, we will understand how do we use or how do we apply simplex method to solve a linear programming, especially a linear programming problem which has got more than two variables. So here in this question, it is having x1, x2, x3, three variables or three decision variables. Question is maximize z, which is equal to 10 times x1 plus 15 times x2 plus 20 times x3 subject to these two constraints, 2x1, 4x2, 6x3 less than or equal to 24, 3x1 plus 9x2 plus 6x3 less than or equal to 30. x1, x2, x3 is greater than or equal to 0. First of all, we will have to write this in a standard form. The standard form of the above is, let me write, maximize z, which is equal to 10 times x1 plus 15 times x2 plus 20 times x3 subject to in the previous video we saw about introduction of slack variables. Here we will be doing that because this is having a less than or equal sign. In fact, the constraints are the same in the previous video what we took to understand about slack variables, same constraints. So I will be introducing slack variables. 2 times x1 plus 4 times x2 plus 6 times x3 plus 1 times s1. The second one, it is 3x1, 9x2, 6x3 plus 1 s2, no s3, sorry, no s1, here no s2, and I can equate these to 24 and 30. Since we introduce these slack variables, I will also introduce the same in the objective function with the zero coefficients. So it is 0 times s1 plus 0 times s2. This we call it as a standard form where s1 and s2 are slack variables. And also we will write now non-negativity restrictions, x1, x2, x3, even s1, s2, all are non-negative. We saw that in the previous video, slack variables are also non-negative. So I can together write this as non-negative. Now, once we formed this standard form, once we brought this linear programming problem into standard form, I can now take this into a table. Table will be like this. Here the table is. So some of the terminologies we'll understand. This C suffix B are called coefficients of basic variables in the objective function. That is our CB. So of course, BV is basic variables. CJ is jth coefficient in the objective function. Jth coefficient in the objective function. What is Zj? Here we wrote this CB, whatever here that we wrote what it is. BV we wrote here. CJ we wrote here. What is this Zj? Zj we call it as jth dot product. How to calculate that Zj? We'll subsequently see how do we do it. Now, let me first write this data in the table. So these are all jth coefficient of the objective function. See, if you look into this x1, for that the coefficient is 10. So here I will write 10. Here I will write x2's coefficient, which is 15. J represents the number of variables or number of columns, I can say. Here there are 1, 2, 3, 4, 5. There are 5 variables. So you will have 5 J's, means J ranges from 1 to 5. That's what it is. So next one is 20. Next one is 0. Next one is 0. And here we have 2, 4, 6, 1, 0. And then right hand side coefficients are, right hand side constants are 24. And here it is 30, the second right hand side. Here it is 3, 9, 6, 0, and 1. In the previous video, we understood what do we mean by basic variables. Wherever the identity matrix is getting formed, we may notice here 1, 0, 0, 1. Here the identity matrix is getting formed and the corresponding variables are S1 and S2. So that becomes your basic variables. Here I will write S1 and S2. Now, what is CB? Coefficients of the basic variables in the objective function. Go to objective function. This is the objective function. The coefficients of the basic variables are 0 and 0. So here I will not write 0 and 0. Now we will calculate what is called as Cj minus Zj. So since there are 5 columns, 1, 2, 3, 4, 5, you have 5 Cj's minus Zj's, means first I will write C1 minus Z1, then C2 minus Z2, then C3 minus Z3. First of all, what is all this? Let us calculate. C1. C1 is nothing but 10 because the jth coefficient we say. So C1 means first coefficient, which is 10, minus of, how do we calculate this dot product? First dot product, first, that is jth dot product. Z1 means first dot product. First dot product is calculated as, choose the first column, that is 2 and 3, multiply that with this CB, means 0 into 2, 0 into 2, then add 0 into 3. So we get 10 minus 0, it becomes 10 only. So fill up here 10. Then next one, C2. C2 is the second coefficient, which is 15. And Z2 is 0 into the second column elements, 0 into 4 plus 0 into 9. 0 into 4 plus 0 into 9, which is 15. Then third one, 20, let me write 20, minus of 0 into 6 plus 0 into 6. 0 into 6 plus 0 into 6. So we get 20. Now C4 minus Z4, C5 minus Z5. What is C4? It is the fourth coefficient, which is 0. Fifth also is 0. So here both places I will write 0 and 0. And then the dot product. Here we have 0 into this 1 plus 0 into 0. 0 into 1 and 0 into 0. So ultimately it is 0 minus 0, so it is 0. Then the fifth dot product, 0 into 0 plus 0 into 1. 0 into 0 plus 0 into 1. This also you get 0. So I can fill up the same numbers, 15, 20, 0, 0. Actually speaking, we need not calculate. Once you have the coefficient of basic variables as 0 and 0, you will get Cj minus Zj, the same elements what you are having in Cj. But still, I wrote all these things because subsequent tables also the same type of calculations will be there. That's why I explained it here so that the subsequent calculations will be easier for you to understand. So the calculations will be the same even for the subsequent tables, whatever we are going to do. So we got these as the Cj minus Zj. values. Okay. Now, what is the step? Next step. Next step is, let me write it here. Identify maximum positive Cj minus Zj and mark that column with a downward arrow mark. Downward arrow mark. So what does that means? Among all the Cj minus Zj, we may notice the maximum is 20. Maximum is 20. This column, I'll have to mark it with a downward arrow mark. Like this. What do I mean? This indicates that this x3 becomes your incoming variable in the subsequent table, right? Let me just a moment. Now, first of all, that column is called pivotal column. Pivotal column, or another name for it is key column. The corresponding variable, sorry, it is variable. Corresponding variable is called incoming variable. Corresponding variable is called incoming variable. Here is called incoming variable. Here the incoming variable is, what is that incoming variable? Arrow mark is here, variable is x3. So incoming variable is x3. Means in the subsequent table, this variable will enter the system. That is the meaning of this particular arrow mark, right? Okay. Now, how do we calculate this theta, which we also call it as ratio? Theta suffix I means ith row's theta value. Ith row's theta value is equal to RHS of that row, of that ith row, divided by pivotal column element of that row, right? So what does it mean? Go back. 24 is the first row. Pivotal column element is 6. So 24 divided by 6. This is our, I'm sorry, this is 6, not 36. So this is 4 for first row. And if you look into the second row, the right hand side is 30 and the pivotal column element is 6. So 30 by 6, that is 5 for which row? Second row. Okay, now let us go and fill up 4 and 5 here. What is the next step? Next step is identify the least positive theta value and mark that row with an outward arrow mark, that row is called pivotal row, or key row, full stop. The corresponding variable will be the outgoing variable will be the outgoing variable, means that variable will move out of the system, in the subsequent table. Let me write it clearly. In the subsequent table. So we know the least theta value among these two, least positive theta value. Did I write that? Yeah, least positive theta value. So both are positive, 4 and 5. Least positive is 4. Mark that particular row with an outward arrow mark. Simply like this. So this arrow, whatever first row becomes your pivotal row, and the corresponding variable is S1. So I can write here the outgoing variable is S1. That is what it is, right? Yes. So here we have this X3, outgoing variable is S1. So the intersecting variable means the intersecting element. The intersecting element, we call it as pivotal element. The intersecting element of pivotal column and pivotal row is called pivotal element. Here it is. Let me mark that with the red color, the pivotal element. Yeah, this first row is your pivotal row. This third column is your pivotal column. So the pivotal element is this particular 6. That is your pivotal element. Here it is 6 in the first row. In the subsequent table, this pivotal element will be divided to all the elements of that row, and the other row elements or to be found or to be found by doing a row operation based on the basic variables and our requirement of the corresponding identity matrix. What is all these things? We'll understand it. Identity matrix. Okay, now let us see the table now. Okay, now this Cj values will remain as it is, the same. What were those? It was 10 here, 15 here, 20 here, 0 here, 0 here. Okay, now we might have noticed here outgoing and incoming. Which is outgoing? Incoming variable is x3 and then outgoing variable is s1. Here it is. Let me mark it. Outgoing variable is s1, incoming variable is x3. So what we will do is, we had earlier here s1 and s2, that s1 will move away now. Instead, x3 will come in. And this s2 will remain as it is, s2 only. Now, what is the coefficient of the basic variables in the objective function? For x3, it is 20. For s2, it is 0. Now, already I addressed it here. We need to divide the pivotal element to the corresponding row, all the elements. Means, going back here, all these elements, that is 2, 4, 6, 1, 0, 24, all these 6 elements has to be divided by 6. So 2 by 6. 2 by 6 is nothing but 1 by 3. Write down here 1 by 3. Then going back again, 4 by 6. 4 by 6 is 2 by 3. 6 by 6 will be 1. And then 1 by 6 is 1 by 6. 0 by 6 is 0. So next element is 1 by 6 and then 0. This is 1 by 6 and this is 0. Okay. Now, how do we evaluate the second row elements? We will use this particular formula. New row 2 elements can be evaluated as something times this new row 1, whatever we wrote now, new row 1 elements, plus old, we are calculating new row 2. So here I will write old row 2. Means, remember, when we have earlier in the first table, based on what is where the identity matrix is, we identified the basic variables. Identity matrix appears here. It is appearing here 1001. So the corresponding variables s1 and s2, we wrote it as basic variables. Now basic variables are already identified. We need to form the identity matrix accordingly. Means basic variables are already identified as x3 and s2. So that particular column should form an identity matrix. Means here we have 1. That is the reason we divided every element with a pivotal element to make this element as 1. Now below 1 you need to have 0 because that is a basic variable. So 1, 0 and then s2 0, 1 means here I need to get a 0 here. Here I need to get a 0. So basically this formula we wrote it mainly to make this element as 0 because we need that basic variable should form an identity matrix. Means we need 1, 0, 0, 1. So if we could able to make this as 0, this will automatically become 1, which we can see now. Now, what is that number to be multiplied with the new row 1? So for that, what we have to do is go back to this position, whatever is this position, which is second row and third column. Go back and see what is the number over there. Second row, third column, it is 6. So we have to just take an opposite sign of it. Means here we have to write -6. Now, if we do that, let's see what we will get. New row 1 into -6 means -6 into 1 by 3. It becomes -2. -6 into 2 by 3, that will be -4. -6 into 1, it is -6. -6 into 1 by 6, it is -1. -6 into 0, it is 0. And this also we have to divide. Actually, I missed it. When we divided by 6, even the right hand side needs to be divided by 6. 24 by 6 is 4. So let's fill up there with the 4. Okay, now here, the right hand side, I'll put a vertical line just to segregate between these elements and right hand side. That has to be multiplied by -6. So it is -24. Now, these elements, what is this we did? We did this part, -6 into new row 1 we did. Now, this is to be added with the old row 2. What is old row 2 elements? Let us go back. Capture those. 39601. 396. 39601. And here it was 30. Now, let us add these two. This will become 1, this will be 5, this will be 0, this will be -1, this will be +1, this will be 6. Now, these elements can be filled in here. That is our new row 2 elements. So it is 1, 5. See, we got 0, -1. And here again, we are our interest is in 1 only. We got 1 automatically. And this is 6. Okay. Now let us calculate Cj minus Zj values. Now, when you do Cj minus Zj values, whichever basic variables which are occurring here, which is x3 and s2, those columns we need not calculate. We can simply write that as 0 here. Means x3, go to x3 column, write the Cj minus Zj as 0. S2, go to S2 column, write it as 0. Even when you try to calculate Cj minus Zj for this position, you will get 0 only, which you can try it out. So I can reduce the number of Cj minus Zj calculations. Instead of 5 calculations, I am reducing it to 3 calculations. So what are the things we are supposed to calculate? C1 minus Z1, C1 minus Z1, then C2 minus Z2, we are calculating, and then C4 minus Z4, C4 minus Z4. Now what is C1? C1 is the first coefficient, which is 10. Then C2 is 15. C4 is 0. Minus of Z1. Z1 is 20 into 1 by 3, which is 20 by 3. And then 0 into 1. So plus 0. This will become now, this LCM will be 3. So 3 into 10 is 30. 30 minus 20. So it becomes 10 by 3. So I can write here 10 by 3. C2 already I wrote. Z2 is this 20 into this 2 by 3, which is 40 by 3. Then 0 into 5, it is 0. 45 minus 40 by 3. So it is 5 by 3. So here it is 5 by 3. Then the next one, 0, that is C4, I wrote it already, minus of Z4. Z4 means it is 20 into 1 by 6, 20 by 6. Then 0 into -1, 0 into -1 is 0. So we get what? Finally, minus 20 by 6. So I can write here minus 20 by 6. So we calculated all the Cj minus Zj values. Again, we are supposed to identify what is the most positive Cj minus Zj. Positive means I need to check only these two, 10 by 3 and 5 by 3. Most positive is of course 10 by 3. So I can put an inward arrow like this. So your pivotal column is the first column. Now I can calculate the theta. How do I calculate? 4, that is RHS divided by the corresponding pivotal element, which is 4 divided by 1 by 3. 4 divided by 1 by 3 is the same as 4 multiplied by 3. So it becomes 12. Then next one, 6 divided by 1, it is 6. So among these two theta values, we need to identify the least positive. Least positive is this 6. Let me mark it with an outward arrow mark like this. Okay, so now the pivotal element is the intersecting element of pivotal row and pivotal column. Pivotal column is this, pivotal row is this, intersecting element is 1 only. Our interest is actually to make this element to 1, like we earlier did the pivotal element. This 6, we made it by 1, made it to 1 by dividing everything by 6. So we got this as 1. But now already it is 1 only. You need not do anything. That means this next table, I can write the same elements because it is already having a 1 in it. So that means this S2 will go out, will move out because that is the outgoing variable now. X1 will come in, incoming variable. That means instead of S2, this X1 will come in the subsequent table. So how the subsequent table will be? We'll write that subsequent table. Yeah, so now X3 will be X3 only, no change. I'm sorry, let me make it black color. This will be X3 only, no change. Whereas this S2 is moving out, instead X1 is coming in because S2 is the outgoing variable now, X1 is the incoming variable. So here I will write X1. Now, what are these becomes the basic variables. What are the coefficients of these basic variables? Let me copy the numbers 10, 15, 10, 15, 20. This is 0, this is 0. Yeah. So for X3 now the coefficient is 20. X1 now the coefficient is 10. Okay. Now we already decided already it is 1, so we'll write the same elements 150, 150, and then -1 and 1. And then right hand side is 6. Now above this pivotal element, I am supposed to make it as 0. This one has to be made 0. And I am going to find out now the new row 1 elements. New row 1 elements. Let me write the formula. New row 1 should be something times new row 2 plus, since we are calculating now new row 1, here I will write old row 1. Okay, what is to be multiplied? We will have to go to this position wherever we need a 0. Here we need a 0. We'll go to that position. Consider that number's opposite sign, means 1 by 3 here. Here I will write -1 by 3. That's all. So now multiply all these elements with the -1 by 3. 1 into -1 by 3, -1 by 3. -1 by 3 into 5, -5 by 3. -1 by 3 into 0, it is 0. -1 by 3 into -1, it is +1 by 3. -1 by 3 into 1, it is -1 by 3. minus 1 by 3 into 6, it is minus 2. I'm just putting a vertical just to segregate between actual elements and the right hand side. To be added with what? Old row 1. What is old row 1? This one. 1 by 3, 2 by 3, 1. 1 by 3, 2 by 3, 1. And then 1 by 6 and 0. And then 4. Adding these two, we get 0. Here we have minus 5 plus 2 by 3. It is minus 3 by 3, so which is minus 1. This will be 1. 1 by 3 plus 1 by 6. LCM is 6. So this becomes 2 plus 1. So it is 3 by 6. 3 by 6 is nothing but 1 by 2. So here it is 1 by 2. Here it is minus 1 by 3. So let me fill up this. It is 0, minus 1, 1, 1 by 2, minus 1 by 3, and this is 2. Now let us calculate Cj minus Zj. As I told you, whichever basic variables are occurring here, that particular column I can write the Cj minus Zj as 0 without calculating. X3 I can go and write it as 0. Even if you calculate, you will get the 0 only. X1, that column I go and write 0. Now what are supposed to be calculated? What is C2 minus Z2? C2 is 15 minus of Z2. Z2 means 20 into minus 1, which is minus 20. And then 10 into 5, it is 50. So we get 50 minus 20, it is 30. 15 minus 30 is negative 15. So here I can write minus 15. Then we are supposed to calculate C4 minus Z4. C4 is 0. Z4 is 20 into half. 20 into half is 10. And then 10 into minus 1, it is minus 10. So inside the brackets, it is 0, 0 minus 0 is 0 only. Next is C5 minus Z5. So let me fill up that 0 here. C5 minus Z5, it is 0 minus of 20 into minus 1 by 3, it is minus 20 by 3. 10 into 1, it is 10. So it is 0 minus of LCM is 3 minus 20 plus 30. So inside the brackets, it becomes 10 by 3, but there is a negative outside. So ultimately, it is minus 10 by 3. So it is minus 10 by 3. So now, which is the most positive Cj minus Zj? Actually, it is nothing because this is 0, this is 0, this is 0. 0 is definitely neither positive nor negative, and these two are negative. That means there is no Cj minus Zj, which is most positive. So at this stage, we say that we arrived at or we reached the optimality. So I will say here, since all Cj minus Zj are either less than or equal to 0, we reached optimality. Now, what is the optimal solution? Optimal solution. Optimal solution, we are interested in finding out what is the value of x1, x2, and x3. Now, how do we find? Just go to this. Whether x1 is available as a basic variable? Yes. What is the RHS for it? It is 6. So fill up here 6. Means from this itself, I can find out x1 it is 6, x3 it is 2. Next, do we have x2 in the last table? No, it is not there. So x2 should be 0. Do we have x3? Yes, we have 2. So 2 is the answer for it. Now we got x1, x2, x3 values. We can find out max z. Where is that original objective function? Let us go to that. 10x1 plus 15x2 plus 20x3. 10x1 plus 15x2 plus 20x3, which will be 10 times 6 plus 15 times 0 plus 20 times 2. So this becomes 60 plus 0 plus 40, which is 100. So our x1, x2 values are 6, 0, and 2, and the maximum z value is 100. That is the solution for this particular linear programming problem. In case if you find the contents to be useful to you, I request you to please like it, share it with your friends, and also subscribe to my channel. Thank you.